Okay, so now let's go and get in, let's actually practice expanding our following binomials. Now, for this one, I only chose examples to the fifth power. I'm not really sure why I added in this third example. Maybe I was thinking of something else. Actually, you know what? Let's make that a negative. That's what we'll do there. I'll have a little fun with that. I think that was supposed to be a negative, or at least I'll change it so it is a negative. All right. So in this one, x plus 3 to the fifth. Now, when we looked at this, we've only really kind of gone up to the fourth, right? So if we're going to go to the fifth, the easiest way I like to do it is let's just, pick our terms. Forget about, for the moment, we did do the, okay, so we do have the expansion to the fifth power, at least those factors. So what we're going to do in this case is, what I like to do is first let's do the values, or let's do the descending powers, okay? So if I'm going to do x plus 3 to the fifth, I know my first term, x. Now, since it's all positive, I'm not going to worry about the parentheses, but once we get into negatives, it's going to be really important that we make sure that we use the parentheses. But for this case, I'm not going to use the parentheses, just for a little bit of sake of time and clarity. So I'll have x to the fifth, and then I'm not going to write 3 to the 0 because that's just going to be 1, plus x to the fourth. Oops. Let's give ourselves a little bit more space. Actually, I'm not going to have that much more space. So x to the fourth. And now, if this is 3 to the 0, then we'll have 3 to the first, plus x to the third, 3 squared. And these are all multiplied by each other, FYI. So if you didn't use parentheses, if you use parentheses, you didn't have to worry about that. Plus, let's do x squared, and then this would be an ascending. The next ascending power would be 3 cubed, plus x to the first, plus, times 3 to the fourth, and then last but not least is x to the 0, which I'm not going to write, and then 3 to the fifth. Okay. So, and then the last thing we can do is we can just go and take these coefficients and then use these as a multiple there. So the coefficients that we found are 1, 5, 10, 10, 5, 1. So let's make sure that we have those. So we're going to multiply this by 1, 5, 10. All right, I'll just multiply it 10, 10, 5, and then 1, right? So good. Looks like everything is, we have enough terms and everything else. Now we just need to figure out, what is 3 raised to all these powers, because x raised to the powers is, going to be rather simple. So we have 1 times x to the fifth. Well, that's just going to give us x to the fifth. Let's see, plus 5 times x to the fourth times 3 to the first. So 3 to the first is 3. 3 times 5 is 15. X to the fourth. And then we have 3 squared, which is 9. 9 times 10 is going to be 90. X cubed. Then we have 3 cubed, which is 27. 27 times 10 is going to be 270. So we have 270 x squared. And then we have 2754. That's going to be 81. 81 times 5 would be 405. Let's just go ahead and do that so I just don't make sure I make a mistake. So 3 raised to the fourth, and then times 5, 405. Good. So we have 405 times x. And then 81 times 3, 243. Let's just check that. 3 raised to the fifth, 243. And boom, there we go. We're all done. Awesome, right? Wasn't that bad. Now, but the reason, for here, you can just, so again, to kind of work on the steps, I like to, do the powers first, get those all in descending order, and then I like to, throw in the coefficients from the Pascal's triangle. All right. And then we basically just simplify our results. Now, once we get into an expression where we have like a coefficient and a subtraction between the terms, I think it's important to rewrite everything with parentheses, because then when you come into organizing everything, or adding them in the binomial expansion, it's really helpful to have those parentheses in there. So therefore that reminds you that's a -1. That reminds you you're raising a 2x, to whatever power. You're not just raising the x, because that's probably one of the more common mistakes. People will forget about the coefficients and they'll forget about the negative. So I like to rewrite it with parentheses. Now let's just use a different color so we don't get the problems confused. And let's go in our descending order. Now in this case, I'm just going to write everything out so we can see it. So we have 2x to the 5th power, and -1 to the 0 is just going to be, let's just write in there, why not, -1 to the 0, and then plus 2x to the 4th times -1 to the 1st plus 2x to the 3rd times -1 squared plus 2x to the 4th times -1 to the 3rd, and you can see I'm running out of space. Let's see, we got one more. Plus 2x to the 5th times -1 to the, wait a minute, what happened here? 5, 4, 3, and then I stopped going. I start reverse them. So you got to be a little careful here because obviously I'm making some mistakes. All right, so that is 2x squared, and this would be to the 3rd, so this is to the 1st power. So that's 5, 4, 3, 2, 1. This is going to be to the 4th, and then I got to do one more. So, and you can see why I didn't want to do to the 6th and 7th here. It gets kind of, can get kind of crazy. 2x to the 0. I did 0, yeah. Let's just show the 0. And then -1 to the 5th. Okay. Whew. Now, the other thing is, remember, we have these coefficients, right? We have the coefficients that we need to bring in. So let's go and bring those in back as 1. Now, I'm going to put them in parentheses just to remind myself that I'm multiplying. So that was 1, 5, 10, 10, 10, I'm messing up my terms, 3, oh, I did 3 10s. You can see how my work can get kind of crazy here, right? All right, so that is -3, so that's going to be plus, okay, so then that becomes a 5, and then that's a 1. Okay, so 1, 5, 10, 10, 5, 1. And that's exactly the coefficient factors that we figured that we are going to need, which is, from here, 1, 5, 10, 10, 5, 1. And we have that many terms, and everything worked out. All right, so now let's go ahead and simplify everything. So now we're taking 2x raising to the 5th. So 2 to the 5th power is going to be 32. And we have -1 to 0, which is just going to be 1. So we have 32x to the 5th. Let's keep this in purple. Good. So we have 2x to the 4th. So 2 to the 4th power is going to be 16. Let's write this on there. So we have 16 now, because here's where a lot of people, yeah, let's make this show. Let's just go through this. So -1 times 5. So -1 to the 1st power is -1. So -1 times 5 is now a -5. And then we have a -5 times 16, which is going to be -80. So I have -80 x to the 4th. And again, that kind of goes back to that pattern of when you have a negative, a odd power, a negative term raised to an odd power, it's going to make it negative. But again, that's only assuming that both terms are obviously negative, which was the reason why we did that other problem, which we're going to do the other problem. In this case, I have -1 squared, which is just going to be 1. And in this case, I have 2x cubed, so that's going to 2x cubed is going to be 8x cubed. 8x cubed times 10 is going to be 80x. So I have plus 80x cubed. In this next one, I have -1 cubed, so that's going to be a -1. -1 times 10 is a -10. 2x squared is going to be 4x squared, so 4x squared times 10, or -10, is going to be a -40. Okay. Moving on to the next one, -1 to the 4th is just going to be 1. 2x to the 1st is just 2x, so 2x times 5 is going to be a +10. 10x, sorry. And then last but not least over here, we have that becomes a 1, that's times 1, and that's times a -1. Okay, and so what you can see in this case is by multiplying all of these out, one thing that's also kind of important is notice that we have alternating signs, positive, negative, positive, negative, positive, negative. When it was positive, we didn't have that. Everything was positive. And I think that, let's look at the case here. Again, with this one, with the negative, positive, negative, positive, negative, positive, and this one ends in the positive. Or but that's raised to a positive, that's raised to an even power, and it's negative, and it ends in a positive. So just some kind of like things to start looking out for. Now in this case, we're going to do with a -3x and a -2. So exact same kind of process. I'm going to write this in red though, and down below. And I know I'm kind of like skipping out some of the work. I'm just saying it out loud. But that's the case. I don't want to make this like 20 minutes of you guys watching just my algebra. The main thing is, can you find the really the kind of pattern with the descending powers and as well as the coefficients, and then really the algebra. I mean, most of the time if you have a calculator, I'm doing a lot of it in my head, so hopefully I haven't made any mistakes yet, but that's majority of where where a lot of mistakes will come after you have identified the patterns. All right, so let's go and wrap this one up here. Let's go and do this. I'm going to take up all the space that I can here because I can. So first one, we have -3x to the 5th. Let's just do, let's rewrite this here. So I can rewrite this as a -3x plus a -2 to the 5th. Okay, so therefore that's going to be a -2 to the 0 plus -3x to the 4th. I gotta like wait for that to come over. Times -2 to the 1st plus -3x cubed times -2 squared plus -3x squared times -2 cubed plus, hopefully I'm not going to run out of space. No, I got plenty of space. Plus -3x to the 1st times -2 to the 4th plus -3x to the 0. And again, you don't really need to write these, but I'm just writing them in there for kind of accounting purposes to the 5th. Okay, so now we have both negative. Let's kind of see what happens here. So -3 to the 5th, I kind of forgot what that would be. We obviously know that, let's go and put our coefficients in here first before we start doing that. So that's going to be 1. That's going to be times 5. That's going to be times 10. That's going to be times a 10. That's going to be times a 5. And that's going to be times a 1. Okay, so we have enough terms. Good. Let's actually let's simplify this. Actually, let's do a second 2 rounds. Just to kind of clear things up. So -3 to the 5th. I don't even want to do this in my head. I already did some math in my head. So let's just do 3 raised to the 5th is going to be 243. That's right. And then 243 times -2 to the 1st. So that's going to be 1. So I'm just going to leave this as, and then 1 times anything. So it's going to be a negative 243. Again, it's negative because -3 is being raised to the 5th power. X to the 5th. To the 4th is going to be 81, so I remember that. And then times 5, 81, which was 81 times 5, which is 405. But then it's times the negative. Now here's an important thing. Look at how my negative, look how I wrote that. That's bad, right? Because really, your negative, if you write it like that, that is wrong, obviously. It is -3x to the 4th times -2 to the 1st. So you got to be careful with your parentheses. I'm not sure why I wrote that, but that's a -3 raised to the 4th. So since it's being raised to an even power, it's going to be a positive 81. And then I have a -2 times the 1st. So let's just see. I'm going to have -3 raised to the 4th, which I already did this. 81, times 5, which is 405, which I already knew, and then times a -2. So that's going to be a -810. And x to the 4th. but I just like using the calculator as I can because I don't want to make any mistake, even though I've already done most of these. Now, negative 2 squared is going to be 4. 4 times 10 is 40. And then I have negative 3x cubed, which is a negative 27. So let's just do, so 27 times 40 is 1,080. And again, that's going to be a negative because that's a negative 27 when you take negative 3x and cube it. So therefore, that's going to be a negative 1080 x cubed, because that was positive, that's negative. Okay, good to go. This becomes negative 2 cubed is negative 8. This becomes positive, which is a positive 9. And so 8 times 9, 72 times 10, so it'd be 720. Oh, 9, yeah. I just want to multiply everything times 10. 720. Yep, good, okay. And that's positive and that's negative. So this is going to be a negative 720 x squared. Negative 2 to the 4th power is going to be a positive 16 times a negative 3 times 5 times negative 3, so it's negative 15 times positive 16. I don't know off that top of my head, but negative 240, which I probably should have. So that's going to be negative 240x. And then I have a negative 2 raised to the 5th power, so that's going to be negative 32 times a negative 3 to the 0, so that's just 1. So therefore, that just ends up being a negative 32. So the important thing to notice here is when both of these terms are negative, you can see that all my terms are negative, right? So kind of interesting. Positive, negative, raised to a positive power, raised to an odd power, has alternating signs, ends at a negative. Positive, negative, raised to an even power, and is alternating signs, ends with a positive power. And when they are both positive, you can see that all the terms are going to be positive. So just a couple of characteristics for you to kind of like visualize as we're kind of doing this, for you to kind of see that, for you to kind of see like the differences here, the binomial, expansion. And again, like a lot of this is, not really as necessary. I don't really, expect this to be of much use. I mean, obviously there are going to be problems where we are going to need to expansion, but a lot of times what we're most going to be concerned with the expansion is finding a given term within the expansion. And that's something that's not going to take as much work. So this is good just for kind of like seeing the patterns, following the patterns, getting used to it, checking up on your arithmetic, and following, order of operations and so on and so forth. But the most use that we're going to get out of this is really just finding individual terms, which we'll get on with the next example.